All right, so this is find the solution to this system. And when you do a system of equations, when you have two equations and you want to find out the x and y value that will solve them both, graphically you can find just the place where they cross. If you graph each line separately and then you look at the one point if they cross at a single point, and it's not a special case, which I can talk about in a bit. If it's just a regular set of two different equations, different slopes, and they cross once, then that one point where they cross will solve both equations. And the reason is this. The big idea is this. All along any particular line, if you take that x and y value and plug it into the equation, it'll solve that equation. So if you're on one of the lines, you take the coordinates of the point on that line and it'll solve that equation. But it won't solve the other equation unless you're also on that line. So where is the place where you're on both lines at the same time? The point of intersection, where they cross. Make sense? So I'm going to move this over just so we can do, we can mark this. And let's take a look at this. Okay, I'm going to graph this first one here in pink. Okay, this one. And what am I going to do when I graph it? Well, the first thing I'm going to do is I'm going to go to the intercept. This number is where the equation, where the line will cross the y-axis. So I'm going to go to 1 on the y-axis. I'm just going to use this first graph and say, let me do this one in pink. Right here is the value of 1 on the y-axis. Now, from there, you would rise 2, run 1. So rise 2, run 1. Right there, rise 2, run 1. So that actually looks like this pink line. This is this pink line being graphed right there. Okay? So now I'm going to do the same thing for this one, the green line. Okay? And I go here to -1 because, again, what's the y-intercept? It's -1. So -1 is where it's going to cross the y-axis. And then from there, the slope is -3, so we rise -3, meaning drop 3, run 1. And aha, look at that. That is the graph, the two graph lines. So I should have that in green, like that. Okay. Interesting. So what this suggests then is that I could take the point -0.4, I'm going to write it over here, -0.4, comma 0.2, and I could plug that x and y coordinate into both equations, and it would solve the equations, both of them. So let's do it. That just happened to be the first one. I was going to do the first graph just because it was convenient, it was right there, but it turns out that actually was the one that has the solution. So -4, comma 2. So let's take each equation. I will take the pink equation, y equals 2x plus 1, and I will substitute in for y what they have up there for y, which is 0.2, and for x, I will substitute in what they have for x, which is -0.4. And of course we have the plus 1 at the end. Now, if I was to solve this, I would say, okay, there on the left-hand side, that's just 0.2. On the right-hand side, 2 times -0.4 is -0.8 plus 1. And if I added 0.8 and 1, it's the same as subtracting 0.8 from 1. I get 0.2. See, it does solve it. Okay? And if I did that for the second equation as well, the green equation, it says y equals -3x minus 1. And wherever I see a variable, I put parentheses, and then I substitute those numbers in. So we're going to substitute in 0.2 for y, and I'm going to substitute in -0.4 for x. Now, this is just 0.2 on the left. There's nothing happening to it. It's just there by itself. Negative times negative is positive. So I have positive 3 times 0.4. It's just like 3 times 4, which is 12. But then there's one decimal place, so 1.2. And when I take away 1 from that, I get 0.2. And it checks out for both of them. So that is the solutions. Okay? If you want to test this thing out, you can go to one of the other points, and I can just show you if you'd like to see it. I can take one of the other graphs that has the point of intersection. For example, let's do this one, marking it in blue here, 0, negative 1. Okay. What if we tried that one out instead? What if it was 0, negative 1? And we plug those in for x and y. Well, let's see. For y, we put in negative 1. For x, we put in 0. And if we then solve this out, you can see that it says negative 1 equals 0 plus 1, or negative 1 equals 1. Not true, because it's not the solution. Okay? It should work for both of the equations. And once you see that it doesn't work for one of them, provided you haven't made a mistake, then it's not the solution. So the answer to this one is A. Let me erase all of these extra marks and just mark this as the final answer. Okay? But essentially, these are quite easy if you know how to graph a line in slope-intercept form, which is the form that these equations are given in. Okay? Slope-intercept form, which is y equals mx plus b. You go to the y-intercept, put a point there, and then you rise and run whatever the slope tells you to do, and you'll graph both of the lines separately, and you'll see the point where they intersect. And since you're already given graphs, all you have to do is basically graph the two lines and see which graph has those two lines graphed where they're supposed to be. Yep, hopefully this is just a refresher and you already know how to do this.